Hi class, in this section, which is 3.2, we're going to actually be looking at measurements that are going to allow us to compare data, and also it will allow us to see, well, a measurement of spread of the data. And we're talking about the spread of the data from technically min to max, and also how each of these data values differ with respect to each other. Furthermore, these measurements actually allow us to come up with predictions, which is going to be the last topic of this week. Now, you're looking at the following. If you're talking about raw data, and this is going to be raw data, so the numbers are given in this form. If you're given raw data, let me just label it as raw data. Then these are the formulas that we're going to use to evaluate the population or the sample standard deviation or the variance. And as I stated, these measurements allow us to come up with predictions in terms of the spread of the data, and also how each data value differs with respect to the mean. So all the formulas will be provided in a future exam or quiz. And also, we're not doing these on an exam base as well, step by step. You're going to be doing the shortcuts. So let me explain why first this section is actually introduced. And let's take a look at this example. And what they're saying is, what problems could you see by analyzing the measurements of the center? And one of the main problems that I see is that value is suspicious. It's actually an outlier. Now, as we're analyzing this small data set, one of the basic measurements that we would be evaluating, it's technically, well, X bar. And I'm just assuming that it's a sample because it says exam scores. If it wasn't a sample, they would have mentioned this is a population. So in this case, this is the sum of the x's, divided by the values of n. Now, please evaluate that into a one variable stats, and we'll compare answers to see what you're getting. So please punch it in. So please evaluate it into a one variable stats, and let me actually just double check that we do have all the values. So 87, 88, 90, 95, and 12. And as you run a one variable stats, I'm actually looking at 74.4. So the mean is 74.4. And in this situation, you really couldn't predict that most of the scores are actually C's. If you actually analyze the data set, most of these are actually above the 80s. You have 87, 88, 90, 95. The value that's actually pulling the mean is technically the 12. So in this case, the 12 is definitely an outlier. It may belong to the data set, so you typically won't remove it, but I just wanted to give you an example of why this section is introduced. Now, just for this one, but you're not removing values of your data set unless stated. So remove the 12. And then the actual scores, or the new data set, if we remove the 12, it's going to give us an 87, 88, 90, and 95. Now, if you evaluate the actual mean now, what you would find out is that this specific one, it's actually pulling the actual mean towards its position. So if we were to do, in this case, the mean of this data set now, and technically I just removed it so that you guys see it. the new value that I'm obtaining, it's an average of 90. And in this case, you would actually say that, well, in terms of a mean, most of the scores are in the 90s, which is technically the average. And because of this, the measurements of the center are not the best ones to come up with predictions. They are actually pulled by the actual extreme values. So that's why we have another set of measurements, and that is the population and the standard deviation, which is a measurement of spread of the data and how each value differs with respect to the mean. So that's actually it for example 1. I just wanted to illustrate that even though the measurements of the center are very good to evaluate, they're not the best in order to come up with predictions. So don't worry about any of these formulas that will be given to you. You just need to know when to actually utilize them. So they will be printed on your future midterm exam. Okay, let's take a look at example 2. Now, some of the homework problems may ask you to do these calculations the long way, and we're only going to do this for 2 problems, example 2, and then another one on the reading where you're doing the problem the long way. And then for raw data, you're just going to be evaluating, the shortcuts on the calculator. But let's do this one the long way. Now, what you technically have here, it's actually it's a sample value. And if you're going to evaluate these the long way, you're going to actually have to start with the variance may be actually the best one, and then go in that format. Now, the variance, since you have a sample, is s squared. So technically, it'll be this one. And I strongly recommend to use this formula. Both of these formulas are used interchangeably depending on which one it's easier to use. So in this case, the actual variance, it's going to be s squared, and this is equal to, and notice on the top we have a mess. It's going to be the sum of xi, which represents every x value minus the mean squared, divided by n minus 1. So this is equal to the sum of x minus the mean squared divided by n minus 1. The actual standard deviation is just going to be s, which is going to be the square root of the sum of x minus x bar, technically squared, divided by n minus 1. And the entire actual value happens to be, the entire fraction is underneath the actual s. Now, for any of these formulas, you technically need the mean. So we're going to start with the mean. And the mean of this one, it's equal to the sum of the x's divided by n. So this will be technically 1 plus 2 plus 3 divided by 3. Please evaluate that and see what we're getting. Please double check I'm getting the values of 2. That would be the mean of this actual sample. Now next, I'm just going to do columns, and these are your x values. So it's going to be 1, 2, and 3. And then we're going to create a column where we do x minus x bar, technically squared. So you would do 1 minus 2 squared, 2 minus 2 squared, and 3 minus 2 squared for each of these. So this is still under x minus x bar. And some of these are going to be really, really messy for some of the other problems. So we wouldn't really do them by hand, but I still need you to practice this, because on group data, there's no way to actually do this other than the long way. So 1 minus 2, it's negative 1 squared. So let me just write it as negative 1 squared. 2 minus 2, it's technically 0 squared. 3 minus 2 is equal to 1 squared. And this is going to be 1, this is 0, and this is 1. Now, the formula uses the sum of x minus the mean squared. So that's going to represent this value. So this would be the sum of x minus x bar squared, which is going to be the values of 2. And then s squared is equal to the sum of x minus x bar squared divided by n minus 1, which in this case, this is 2 divided by n is equal to how many values you have. So let me write it as n is equal to 3. So this is 3 minus 1, or the actual variance is equal to 2 divided by 2, which is 1. So s squared is equal to 1. Now, let me write the actual, the standard deviation. So in this case, s is equal to the square root of the sum of x minus x bar squared divided by n minus 1, which is equal to the square root of 1. I'm just obtaining that from above. So in this case, s is equal to 1. So s is equal to 1. So for this actual problem, we found out that the variance is equal to 1 and the standard deviation is equal to 1. That would be our main answer for this one. Now, let me pause it for a minute, double check that you're matching on all the calculations. I'll show you where to find the shortcut. Okay, so let me show you on this one. So this whole mess of the evaluation, it's actually not needed. The only thing I need for any problem that I test you, it's going to be, well, where did you obtain the actual calculation, and then final values. So as you can see, it's only 3 values and it's a lot of work. If you were to mess up any of these, the whole calculations are incorrect. So all you need to do is the following. Enter the data set into any of the list. In this case, I have it under list 2, 1, 2, and 3. And then run me a one variable stats. So hold on just a second. I have it under L2. So okay, so run me a one variable stats, and you can actually see here, in this case, we're saying that this is a sample. That is your mean, which is 12, which we obtain here. That's your mean. And then what the calculations of the one variable stats give you are the final answer for the standard deviation and the variance. Well, actually, almost final answer. You may have to do some work. But in this case, if it is a sample, that is your standard deviation. That is S. That is this one here. And then all I would need to do for you guys to give me is the formula, the variable, and then the output of how you're obtaining each. If it's considered a sample, this is your answer. If it had set a population, then this is your answer, the value of sigma. That would be the answer if they had mentioned it's a population. So you only have to do one more the long way. And then for raw data, you can do the shortcuts, which will be the next 2 examples.